Hello everyone, welcome back to Code Oris. This is the next video in the AI agent series. In our previous video we learned about LLM in loop workflow and saw a working example of improving a document through iterative refinement. In this video, we are diving into something super important for AI developers and system integrators. The Model Context Protocol or MCP, and specifically, how MCP server works. So first, what exactly is MCP? The Model Context Protocol, MCP, is an open standard, open-source framework introduced by Anthropic that defines how AI models, applications, and external tools can communicate. Right now, if you want an AI model to use a database, API, or service, you usually need to build a custom integration. That means every AI tool has to be wired separately to every service it needs, which is time-consuming, difficult to manage, and not scalable. MCP fixes this by acting like a universal adapter. Instead of building hundreds of different connections and each one following different standards, now tools and applications can just follow the MCP standard. By following MCP standards, AI models or clients can connect to MCP servers that expose data or functionality. The communication between tools and models is standardized. The model doesn't need to know the internal details of the tool, till the tool also follows the MCP standards. This creates interoperability. Any MCP-compliant client can work with any MCP-compliant server. It is very similar to as HTTP on the web. Without HTTP, every browser and website would need custom communication. With HTTP, any browser can talk to any website. By defining these standards, MCP aims to be that foundation layer for AI integrations, powering the future of AI-driven applications. Now let's zoom into one of the most important parts of this whole system, the MCP servers. An MCP server is a specialized service that implements the Model Context Protocol and acts as a bridge between AI clients, like models or applications, and external resources. In simple words, it's the engine that provides resources, tools, or data to AI clients like large language models, AI assistants, or even developer applications. Let's break this down with some clear examples. A database MCP server might expose structured data, like customers, orders, or sales reports, in a format the AI can understand. An API MCP server might wrap external services, such as real-time weather, financial market data, or even analytics dashboards. And a file system MCP server could allow the AI to access internal documents, research files, or knowledge bases. Important point is, all these servers follow the MCP specification. That means if your AI client understands MCP, it doesn't matter which server it's connecting to. You don't need to write custom code for every single integration. That is where the real power of MCP servers comes. They standardize communication between AI systems and the outside world. Now that we understand what MCP servers are, let's take a closer look at how the whole flow actually works. Think of it like a well-orchestrated conversation between AI clients and the resources they need. Let's understand it step by step. First, the MCP server runs in the background. It exposes endpoints following the MCP specification. Essentially, it's telling any client what I can provide and how you can ask for it. This could be a database, a file system, or an API. The important part is that it follows the same protocol for everyone, so clients don't have to learn a new language for each server. Next, a client like an AI assistant connects to the MCP server via Model Context Protocol. This could be ChatGPT, a custom LLM application, or even a developer tool. The client knows it can talk to the MCP server in a standardized way, no matter which server it is. Once connected, the client requests resources or executes tools. For example, imagine AI assistant needs all users from CRM database. Instead of guessing or scraping data manually, it just sends a well-structured MCP request to the server. The MCP server receives the request, processes it, and responds in a structured, predictable format. This ensures the AI doesn't just guess, it gets real, reliable data in the exact structure it needs. And the best part? Because it's standardized, we can swap servers in and out without breaking your client integration. This will allow to switch database servers and our AI client can still talk the same way. That's the real power of MCP. It makes AI integration scalable, reliable, and maintainable. Now let's talk about where MCP protocol and MCP server is useful in the real world. MCP servers aren't just theoretical, they solve practical problems for AI applications across enterprises, developer tools, knowledge systems, and more. We will see the use cases of connecting LLMs to company databases, MCP servers for developer tools, and for AI browse internal wikis and file systems. Let's see a use case of connecting LLMs to company databases. Enterprises often store critical data in databases like CRM, ERP, HR, or financial systems. Directly exposing these databases to AI models is risky. MCP servers act as a secure intermediary, allowing AI to query the data without needing database credentials. It just talks to the MCP server, which enforces rules, authentication, and returns structured, reliable data. MCP server validates the request, queries the database, and returns structured results. The Business Assistant app sends a request to the MCP client, which acts as the central orchestrator. MCP fetches raw data from the MCP server or database and, if needed, sends it to an LLM for reasoning or summarization. The LLM can request additional data through MCP, ensuring security and standardization. Finally, MCP aggregates everything and returns a structured, reliable response to the app. Now let's talk about another exciting use case for MCP servers, developer tools. Think about how many tools developers rely on every day like Git repositories for version control, issues tracker like Jira or Trello, and CI/CD pipelines for deployments. Normally, if an AI-based code assistant wants to check open pull requests, view issues, or see the pipeline status, it would need custom integrations for each tool. That's hard to scale and difficult to secure. But an MCP server can wrap these developer tools and expose them as standardized endpoints. So instead of the AI assistant learning how to talk to Git, Jira, or CI/CD individually, it just speaks to MCP. For example, if you ask your code assistant, show me all open pull requests in repository X, the code assistant sends the request through MCP. The MCP server queries GitHub or GitLab or Bitbucket, fetches the PRs, and returns structured, reliable data back to the AI. No custom wiring. No messy API calls. Just one clean, standardized communication layer. And the best part? Because it's standardized, you can swap out Jira for Trello or GitHub for GitLab without breaking the AI assistant. Another powerful use case for MCP servers is knowledge management. Think about how companies store information, internal documentation, wikis, and file systems. Normally, if an AI assistant needs to search or summarize documents, giving it direct access to the raw file system or private wiki would be risky. It could expose sensitive data or break compliance rules. But the MCP server acts as a controlled access layer. Instead of raw file access, the AI makes a structured request like, find all documentation about project X and summarize key points. The MCP server retrieves the relevant documents securely, applies rules and permissions, and if needed, sends the data to an LLM for summarization. Finally, the server returns a clean, structured response back to the assistant. This way, the AI can provide insights and summaries without ever touching the raw file system directly. It's secure, auditable, and standardized. So in short, MCP makes it possible for AI to browse company knowledge safely, turning a file system into a smart, queryable knowledge base. Alright, now that we've seen where MCP servers are useful, Let's dive into a real-world example using MongoDB MCP Server. GitHub code link for this example is given in description. Using Docker Compose script given in code, we have already started MongoDB Community Server in Docker on our local machine. We have also restored the collection and documents in database. We are also running MongoDB MCP Server in Docker. Additionally, we have integrated the MCP server with MCP Inspector, which we can use to query our MongoDB database. Using Mongo SH, we can connect to the MongoDB and can see the restored database and collections. We have multiple collections, such as airline, airport, inventory_hotel, and route in our database. Instead of writing a custom integration for each collection or database, our AI assistant can query MongoDB directly through an MCP server. This way, the AI assistant doesn't need to know how MongoDB works internally. It just sends a simple MCP request, and the server translates it into the correct MongoDB query. For this demo, we are using MCP Inspector as our AI assistant. Here, we are accessing MCP Inspector and connect it to MCP Server. Let's connect to MongoDB Server using Connect tool. We can see the different resources and tools available. Now we can use other tools to get information from a database. Use list databases to list all databases and list collection to list all collections in a database. We can using find tool to run any query on database. Here we are accessing all documents from airline collection where country is United Kingdom. We got 39 documents for this query. That's it for this video. In this video, we learned about MCP Server and how MCP Server works. We also went through real-world use cases, including a practical example showing how easily we can connect our AI assistant to MongoDB using an MCP server, with no custom integrations required. If you found this video helpful, make sure to hit the like button, subscribe, and turn on notifications so you don't miss any future updates. Drop a comment below if you have questions or want to see more examples with MongoDB MCP Server. I'd love to hear what you're building. Thanks for watching, and I'll see you in the next video.